Graphene-enhanced circuit breakers could be a longer-lasting, more sustainable alternative to safeguard the electrical grid from faults and hazards. Many different parts of the grid use circuit breakers, like data centers, wind farms, and photovoltaic plants, as well as many different areas of industry. Low-voltage air circuit breakers are the most common, and they are usually lubricated with grease. They work by disconnecting sensitive electrical components from the grid in case of adverse events like lightning strikes or falling trees. However, the grease between their moving components degrades over time, which can potentially lead to device failure, meaning regular maintenance and re-greasing are necessary. Graphene-enhanced circuit breakers replace the grease-based lubrication with a self-lubricating composite combining metal and graphene. The scientists behind the Circuit Breakers project optimized an innovative new coating method based on electroplating. The method is cost-efficient, scalable up to 100 litres, and can be applied to an industrial setting. When applied to moving parts and points of contact, the metal graphene coating quickly builds up a lubricating film. Thanks to graphene's strongly lubricating properties, the mechanical parts can slip and slide smoothly against each other with very little friction. The coating withstands a range of humidities and is resistant to corrosion, preventing degradation for longer and increasing device lifetime without requiring reapplication or maintenance.